Now we're going to take a quick look at the lateral surface area of pyramids. So what is the lateral surface area? A pyramid, the parts are one base polygon, which you can see right here, this hexagon in this example, and then it has n triangular lateral faces, one for each of the edges. If this is a regular polygon, all the triangles match, but it could be an irregular polygon, in which case you could have some triangles that don't quite match. So this part right here with all these triangles, that is called the lateral surface area. Kind of think of it wrapping around the side of this pyramid. Each triangular lateral face has something called a slant height. Now, it's the height of the triangle, but it's called the slant height because when you fold the net back up, it's slanted in from the edge here to the top of the pyramid. So it's not the same as the height of the pyramid, which is straight from the center of the polygon below to the apex or vertex on top. So it is a slant height. It goes from the edge to the vertex. The base will be the side length of the base polygon. So the base of the triangle, and not to be confused with the base, big B, but the little b here is equal to the side length of the polygon. So you could say that the lateral face is going to be the side times the slant height all over 2, basically using the area formula for a triangle. So how do we get the formula on your math chart? Well, we have n of these triangles. We're assuming regular polygon for this example. So if we have n of these, the area is n times 1/2 SL. Remember, the 1/2 SL comes from 1/2 base times height. Just looks different because now we're calling the base S and the height L because it's a slant height. Well, if I rearrange it and put n times S, oh, that's something we've learned, which is the perimeter. And that's where we get our math chart formula. I can replace n times S with P for perimeter, and that is your lateral surface area. Now, an important thing about pyramids is because we have this slant height, has a special relationship with the apothem, which is the base of this triangle here, the height, and the slant height. They all make a right triangle. Usually what you'll end up doing is using either the Pythagorean theorem, because there's a squared plus h squared equals L squared. You could end up using some trigonometry, or you could even use special right triangles depending on the problem to find one of these values. Here's a more complicated one. I've got a regular hexagonal pyramid. I added these pictures in just to make it a little easier. And it has a perimeter of 48. The height of the pyramid is 10. What is the lateral surface area? Well, if the perimeter is 48, well, and I'm trying to find A equals 1/2 P times L, and the perimeter is 48, and I don't know the slant height, so I'm going to have to do some math. So let's start by finding the apothem. So since this is a hexagon, one of the cool things of hexagons is they're made of equilateral triangles. So if this is 8, this radius is also 8. Then I can make a special right triangle where I cut this in half. That's a 60 and a 30, 30, 60, 90. And using my shortcut, I know the apothem is 4 square root of 3. I could have used trig, and I also could have used the Pythagorean theorem to find the apothem here. 4 squared plus a squared equals 8 squared. So anyways, now I have my apothem, which goes down here on the bottom. And the height's 10. Can I find the slant height? Yes, I can use the Pythagorean theorem. So let's go ahead and do that. 10 squared plus 4 square root of 3 squared equals L squared. 10 squared is 100. 4 square root of 3. Each of these are squared. This is going to be 16. This is just going to be 3. 16 times 3 is 48. Your calculator would have also given you 48. Add them together, you get 148 equals L squared. So L is the square root of 148. I could simplify this further, pulling out some of the perfect squares, but for right now, I'm going to be involved in some more multiplication, so I'm not going to mess with it. Now I'm trying to find my area, which is 1/2 perimeter times length. Substituting in the perimeter, which is 48, and L is really slant height, not length, and square root of 148, I get 24 times square root of 148. Now I just grab my calculator, and this is just rounded to the nearest square centimeter, 292 centimeters squared. So let's reflect on some of the questions from this section of the notes. What shape is a lateral face of a pyramid? What is the difference between the height and the slant height of a pyramid? And how are the apothem height and slant height of a pyramid related?